This video is just a short extract from the entire course. If you wish to see all of the videos from this series at higher quality and in far larger screen size, head over to ifskills.com.
Alright, we're going to talk a little bit about setting up for our final render. So we're going to go to our render setup here. We're going to start with our common tab, and we're going to go through and take a look at all the different things that we need to think about. So we're going to start with our active time segments. We're going to render from 0 all the way to 360. Area to render we generally want set to view, not just a selected object, a region, a crop, or a blow up. Now, the output size. We have this set up based on our background image, so the proportions of this are set for that. If we want to go much larger so that we can end up using this in like an HD TV setting, our ability to go all the way down to HD TV and look at 1920, sure, that would be fantastic, but we're going to end up kind of forcing the crop here in the render before we actually want to. So we're going to go back to our custom, and then the 640 by 40 is going to keep our proportions. Now, since the proportion is locked here, what we can do, we can actually set the width to 1920 or larger, and it's going to adjust the height for us to maintain our proportions. Now that's going to make it so that once it's all rendered, an editor, or us within an editing package, could decide that we want to lose more of the foreground and keep more of the upper part of the image. It gives us more flexibility, and it also makes sure that we render the entire image and keep our proportions. So for me, I don't really want to render that big. It takes a whole lot longer to render image sizes this large than it does to render image sizes this large. So we need to really think about what we're going to do with this in the end. If we want to be able to zoom into this image, right now at 640 by 480, we don't leave ourselves a lot of room to be able to zoom in. As we zoom into the image, the pixels that exist aren't going to change. We're still just going to have the same number of pixels. We're just going to make those pixels bigger. So the idea is that if we know at some point we're going to need to zoom into this image, we definitely want to render larger so that the end image here is the right size for what we're going to be doing full screen. So generally speaking, if I have to zoom in, I'm going to want to render much larger image sizes. Now, as we get on here to our render output, right now save file is not checked. I need to click on the files button and tell it where I want to save this. Max is going to default to this render output folder. For now, that's fine. What we can do is give it a file name. So we're going to call this battle. And then I can pick the type of image I want to save to. AVI is generally a good format, but if I want to end up giving this to an editor to make tweaks to, I would typically suggest you render out to the Targa format. The Targa file format is going to give us more options. So when I hit save, it's going to come up with this image control dialog box. Right now it's set to 32-bit, which is going to have an alpha channel built into the image. If I'm not going to have to composite this over a different background, I really only need 24-bit. So that said, I can hit OK, and I can render out to an image file stack. Now, a lot of times though, I don't necessarily need to worry about rendering out to a stack. I can just render out to an actual video format. So an AVI is great for that. So we can render out directly to a full video that we can just play back on our desktop. The downside to rendering out to an AVI is that if in the middle of my animation or the middle of my render, I've got to stop this for any reason, I'm going to end up with multiple AVIs that I've got to figure out what frame I ended on so I can start the next AVI rendering at the correct frame. So the good thing about dealing with an image sequence is that I can just simply look in the folder that I'm rendering to find out what image to start with, or if I have an image sequence, once it's started rendering, if everything is good, all I have to do is check skip existing images, and Max will just pick up with the same frame range. It'll just pick up where it left off and skip the images that are already saved into that folder. So I would say in general, you should always render to a Targa stack. But it's not an absolute. There's so many things about what we do that are not absolutes. So it's at least a good starting point to render out to a Targa stack. Now, that said, I'm going to render out to an AVI. So I've got one kind of finished encapsulated file that we can view a little bit more easily. So with an AVI though, we're still going to remove our extension there and we're going to hit save. Now the AVI setup dialog box comes up as well. If I'm rendering this out to, again, give to an editor, I want to render uncompressed, and it's not going to allow me to change my quality setting because it's uncompressed. It's the best possible quality that can be at render time. Now if I go with the DV encoder, again, no settings there. The MJPEG, I have quality settings. So MJPEG is the motion JPEG compressor. So it's basically like kind of a pre-built sequence of JPEG images. JPEG is a lossy compressor, which means actually information does get thrown away. Which, for what we're doing with photographic type images, JPEGs are a really good quality compressor. It throws stuff away, but it does it pretty intelligently. So most of the time, if I'm rendering out to AVIs, I'll render uncompressed and then use something else to do my compression. For now though, MJPEG is actually going to be pretty good, and we'll drop this down probably about 85. That is a nice balance between file size and image quality. Now, again, we could render it out at 100% and always use something else to drop down the compression so that we control our file size. But if I were going to do that, I would render out my initial at uncompressed, so I've got it at absolutely full quality. And then I can run it through another tool like After Effects or Premiere just to compress it. So the rule of thumb is that what I render out of Max should be as high quality as is possible so that I have options after the fact for dealing with compression and or file types. So let's for now, we'll just leave it at uncompressed. And we go through a couple of these other render dialog boxes here. So under my renderer here, I've got some sampling quality. The higher the minimum and the higher the maximum, the slower it's going to be to render. But generally speaking, if I go low on this and high on this, it gives Max the option to kind of figure out what it needs per pixel as it renders. So the default here is usually pretty good for most photographic type stuff. If you get into architectural work where you've got a lot of real thin lines, your maximum value is probably going to have to come up quite a bit, and it will significantly slow down your render times. Scanline generally you want to enable so you can end up having a little bit faster quality shadows. BSP2 is better for large scenes. Camera effects, like we turned motion blur off because we're using it camera based. Camera shaders, here's where our default glare was that we again turned off. Shadows, when we enable those here, we do usually want them set to simple. It's faster, but if you've got some really complicated scenes that demand it, you may need to go with the higher quality type shadows. Indirect illumination, we're using Final Gather. The higher the number of my diffuse bounces goes, the more accurate the light's going to bounce around my scene. Now, generally speaking, if I'm using Final Gather, I don't absolutely need global illumination. But GI and Final Gather together can make for a real nice kind of light solution to what you're doing. I don't always use them both, but again, for some architectural type stuff, using them both looks really, really nice. It's slower though. Processing, we can allow Max to cache geometry so that it's a little bit faster render time. For a scene like this, though, it's not a significant difference. If we have multiple computers working, we can distribute the buckets onto other machines. So as MentalRay renders, each one of those little boxes that pops up around the screen is what MentalRay considers to be a bucket. We can actually distribute those buckets to other computers. Now, I don't have other computers available, so we can't do that. But MentalRay is a pretty robust rendering engine and is capable of a lot of different things. Under Render Elements, I have the ability to basically add and separate all of the different elements that you see here to a separate image file, whether it's an AVI or a target stack. And if I'm doing a whole bunch of different stuff, and if I'm working for film, I really do want to render out different elements for each different thing. So I would have a diffuse pass, a shadow pass, a lighting pass, the background pass, the hair pass, reflection pass, all these different things will get rendered out to their own different image sequence that Max can even generate a combustion file. Combustion's a lot like After Effects. If you enable this, it can actually create your combustion workspace and bring all of your file stacks back together. So it basically recomposites everything for you. The positive side of doing things that way is that if after you've gotten the render all finished, your editor decides that they want the shadows tinted a slightly different color or the lighting tinted a slightly different color, they want this blue a little bit more saturated blue. If you don't render out to all these different passes, then you'll have to go back and make those adjustments and re-render the entire thing. If everything's its own layer, its own pass, when you go to render or when you want to make those corrections, the editor can simply work on that individual layer to make those corrections in post. And again, working in film, you generally won't have time to re-render all the time. So you want to use these render elements to separate things out as much as possible so that it's more easily tuned or fine-tuned after the fact. All right, so for now, we don't need any of that. We're just going to go back here and we're going to make sure that we're still set back where we want, 640 by 480. We're going to go and check our camera, make sure that our multipass effect is still turned on. Display passes at 6 looks real nice, and then we're going to start rendering. So once this starts rendering, it's probably going to take several hours, if not most of a day, to render all 300 frames. Once it's all done, we'll take a look at it.